Hello friends, in today's class we are going to talk about what is an operating system. We'll see the definition and we'll see the responsibility associated with operating system. So welcome here, and now we are talking about what is an operating system. So I already told you that in the previous in computer system architecture, and we have seen already that there are four contender, and I already told you one definition that between your hardware and your program there is in between them there is someone who is communicating between both of them is your operating system. Okay, and now we are going to formally define the term what is an operating system. Okay, so here the operating system is a program that control the execution of application program, implement an interface between user of a computer and computer hardware. So it's an interface. Okay, that is the important term here in this case. It acts as an interface between what? Between user, and user will run the program, and your hardware. Now, why it is required? Because hardware is such a complex entity, right? Itself is a complex entity, and you cannot expect a user to handle the hardware directly. So there are two views are there. There is a narrow view of computer and operating system, that is a terrestrial computer with application running on it, PC workstation, and there is a broad view of the computer and operating system. Okay, so narrow view is something like a PC that we use. Okay, and broad view is that anything that manages the resource. That is a new term here in this case. So just now we have figured it out that it acts as a intermediary between program or user and the application. And here it is also saying that a broader view of operating system, anything that manages the resources. And in that case it can say that router, okay, that is managing a network, an embedded system, even a cell phone, it is calling as a computer or as an operating system. So any resource that you're having and that is being managed, resource. A resource can be memory, it can be a link, it can be anything. Okay, so any resource, a resource that you are managing. Okay, so now we have two views of operating system, that is one as a resource manager, and another one is intermediary between hardware and user. So there is a two key function of this operating system, is that first one is your abstract machine, abstraction. So if you are familiar with your C and C++, abstraction, it's something hiding the details. Okay, we are not bothered, sir. What is an abstraction? Hiding the details. We don't bother how actually let's say a car works or car brakes works. We don't bother about it. A car gearbox works. We don't bother about it. A car engine work. We don't bother about it. Engine work, how it, we don't bother about it. So we are not dealing with the internal functionality, that what exactly all this system work. We are only interested in what? In driving a car. I know only one thing, that I'll just I'll do the on, I'll do this ignition on, I'll just put the gear, leave the pedal, and it will move, or I'll go for a drive. Okay, so we are only interested in that, but what exactly happening inside a car is really does not matter. And that process where we are not hiding the details or hiding the complexity, okay, from the user, is basically a abstraction. So we want the same functionality to same thing with operating system also, that we want to develop an abstract machine model, hide complex details of underlying hardware. We don't want the hardware thing to be, you know, overwhelmed by this size, overwhelmed by this control function and all. We don't want this. We want to only use that hardware. You tell me how. Okay, so that hides the detail. Provide common APIs, application program interface for applications. So that is also one of the application program interface API. Now I want to develop, let's say, a new program for, let's say, Windows, that I want to run on Windows. So how I'll do it? So for that I need to interact with hardware, and that I needed to develop a, let's say, a software that needed to interact with the hardware. And again there will be some, you know, the same difficulty, and for that reason we have a APIs, Windows let's say API, and that I can use and I can run the program. Simplifies the application. Okay, now there's no 12 application writing. Okay, so that using that APIs I can, you know, simply create an application. So abstract machine model, hiding the complexity. And the second just is the resource manager, and resource is having a very broader, it can be a CPU as a resource, memory as a resource, as I told you that disk is a resource, and network is a resource. Okay, so that is the two main OS function that abstract machine we want to develop, and hiding the complexity. Now, why abstractions are important? Now, why abstractions? Now, the simple reason is that suppose I want to run a program. I want to run a program. Okay, and if I want to run a program, then user, let's say broader, more common, user wants to run a program. Okay, now suppose OS is not there, suppose there is no operating system, then what you will do? Then I must know my hardware. Okay, I know the entire structure of hardware. I must know the entire control signals of hardware. So I must know everything in this case, right? And then I will finally use all this information to run the program. And every time I will do it, every time I will do this same thing every time. And second part is every user will also do the same thing. Okay, so now if I have to do the same task again and again, so rather than having one user every time writing a program, rather than have a single fixed program, a single program that is dedicated for purpose of running. Okay, so, and without this abstraction of things will become very difficult. Okay, it will become really very difficult, you know, to handle the underlying hardware. And that is why, you know, abstraction is important. Now, so this is a view we can think of an abstraction, that it provides abstraction. And how does it provide this abstraction? As by using a system call. Now this is the new term that we know that this part is the hardware and this part is the user application and user, and we have in between that this operating system is sitting. Okay. Now, so there is a hardware, memory, network, disk, printer, video card, monitor. Okay, all these things are there. And how this abstraction is performed by using system call. So what is this exactly? Is a system call is a program only. Okay, so you have an application that is having a system call, that is a read system call, open system call, write, make directory, and kill system call. Now this all system calls related with your file system. Okay, so now you just you copy the file very easily. Okay, you have done this in your operating system. You have deleted the directory very easily. you have created a directly very easily, but every time you understand when you are doing or performing this particular operation, then this kind of the system call reading, opening, writing, make directory and kill system call has been called by whom? By operating system, right? And that makes the things very easier for us. So system calls are what? System calls are nothing but the program, and they are used by whom? They are used by your operating system. User can initiate, but execution is the responsibility of the operating system. Operating system as a resource manager. So abstraction we have seen, and then resource manager. What can be the resource you can think of here? So here the resource can be your it can be across space and time. Okay, so a time sharing resource is there, that a time sharing resource, that CPU is there, a time sharing, that you cannot have a single program running all the time. So all program must share in time, single program, the CPU, and in that case you required a specific scheduling algorithm. Okay, and what are the scheduling algorithms? Something like first come first serve, or shortest job first. Okay, so these are the time sharing resource, and which is nothing but a CPU. Space sharing resource, and which is nothing but your memory. Okay, so now everyone wants to run the program, it has to be allocated memory space, and once the job is done, then it also has to be deallocated. So allocation and deallocation, and that is, as a resource manager, one of the major responsibility in terms of space and time. And this part is also important here, that if you are dealing with this resources, then there must be an efficient utilization of the resource. Okay, so improving utilization, minimizing the overhead, and improving the throughput. Okay, so that is your as a resource manager, it should be. So even that this thing is also true when we are in our human also. If there is a manager, then he wants to utilize all these resources very well. So there is a task, he'll divide the task in time and space manner, and then he just want to improvise the utilization and minimizing the overhead. Okay, now this is also one of the part, that protecting application from one application from each other, and enforcement of the boundaries. So there are operating system codes are also running, right? Operating system code is also running, and user code is also running. So it should not be it should not that a user code should not go and directly start manipulating your operating system codes, and that is also, as a resource manager, conflicting situation must be avoided. This is the another view, that the problem that OS operating system must solve, that time sharing and of the CPU and among application, space sharing of memory, space sharing of disk also. Okay, disk, time sharing access of disk, that is nothing but your disk scheduling, time sharing across the network, that is now there can be many applications that want to use the network, so there must be divided in time. Protection, or already resource manager we have seen, application from one another, user data from one another, hardware devices, and from OS itself. Okay, so the OS is just a program, it need to help from the hardware to accomplish this task. Okay, so all this thing is being done by help of that point is nothing but help of hardware only. So means it has to be utilized hardware very appropriately to accomplish this thing. So the last point is, when an application is running, the OS is not running, When OS is not running, it cannot do anything. Okay, so that is the idea, that at a time only a single program will run. Okay, single program will run. So when application is running, OS is not running, and when OS is not running, it cannot do anything. Okay. So that is a broader view, you can say, of operating system and its definition. Okay, so that's all for this discussion. Thank you.